haven't entered your name and email before, please do so now. I would greatly appreciate that. And we're going to continue on with quality assurance auditing. So Wayne provided the lab training, the virtual lab training, and I believe he probably discussed SOPs for the laboratory. And I just went over a review of some of the standard operating procedures that some of our field research directors have. Well, not only they have SOPs, the quality assurance unit also has its own SOPs. So here we will go over the SOPs for auditing field trials. Okay. So that's what we should be seeing on the screen. Okay. Hopefully everybody can see that. Okay. All right, and we have some new people that have just signed in. Angelo and Prakit. Okay, very good. So we're going to be talking about the in-life inspection of field trials. So this is one of the SOPs from IR4, our quality assurance unit. You can scroll down, please, Nui. All right. So the purpose is to detail procedures followed by IR4 quality assurance to be able to audit and conduct in-life inspections. So in-life inspections means the inspection that an auditor, that a QA auditor is conducting when a trial is actually going on. Okay? So a live event. So the quality assurance officer will coordinate with the field research director. As for the times of inspection, they will be scheduled so that they can be present during the activity. Okay. The number of audits on a study will depend on the length of the study. And see, these are some examples of some of the in-life phases. They could include the test substance application, which is probably the most critical, equipment calibration, sample collection, sample storage, or sample shipment. You can scroll down, please. So the QA tends to focus on some things such as, has the protocol been signed by the study director and sponsor? Determine if there have been any protocol deviations and whether they've been properly authorized by the study director. Check to see that the initial point of entry of all raw data is into the IR4 field data notebook. Independently check representative calculations for accuracy. Check the plot map to see if it adequately describes the location. Check to see that the amount of test substance used has been recorded and that all forms of the test substance shipment, receipt, storage, etc. have been retained and generated and are up to date. Check to see all problems encountered are documented and that SOP deviations have been authorized by the study director. Check the field data book for timeliness and completeness of entries. And then check for any observed applications met the protocol with respect to the amount of the test substance applied. We can scroll down, please. So the inspection will be conducted using a checklist, and we'll be going over that checklist. And then the findings have to be documented and they have to be responded to. Once the inspection has been completed, they will discuss the findings with the field research director and then inform the study director. Okay. We can scroll down a little more. So any findings likely to affect the integrity of the study must be reported to the study director and testing facility management immediately. This can be done by a telephone conversation, email, or fax. If the report is sent to testing facility management and study director simultaneously, utilize the box of the cover page of the audit. Some of the key things to look for are misapplication of the test substance, an application interval that in the protocol that was not met, collection of samples that were not performed, sample shipment that did not take place, sample integrity was jeopardized. In other words, if samples thawed, data collection did not occur timely, any potential fraud, documentation of GLP test substance characterization. Also report if there's any problems if reinspection is needed. Okay. And we could scroll down. I think we're at the end already, right? Okay. So Nui, if you can change the view to the audit. So there was an Appendix A, which is the Quality Assurance in Life form. It's sort of like a checklist. Are there any questions about the Quality Assurance SOP? Okay. So this is a form for the IR4 project, and we use this for the quality assurance to be able to report to the study director their findings. So it includes the title of the study, the ID number, the phase that's reviewed. Does anybody know what the word phase means? Okay. So if somebody knows what the word phase means here, you can type that in the chat box. Okay. The inspection date, who the field research director is, their name, the address, and email. Within IR4, we also have regional directors, but within this study, we will not have them. Okay. Who the quality assurance inspector was, and their contact information. Who the study director is, test site location, and then you go ahead and fill out the checklist. So I don't think anybody has answered. I don't see any answers in the checkbox. So when they say phase, they mean what part of the process did you do the inspection on? Did you audit sprayer calibration? Did you audit application of the test substance? Did you audit the collection of the samples, shipping of samples? So what part of the inspection, what did you view? What did you audit? What activity was going on when you did the audit? And a very similar thing exists for the laboratory. Okay, if you can scroll down, please. So for some of the first general information that the quality assurance inspector will be looking for is the protocol on site. And so here there are boxes. So it's the answers are either yes, no, or not applicable. Okay. Has the protocol been signed and dated by the study director? Is it signed by the sponsor? Are all protocol changes, such as amendments and deviations, properly authorized? Okay, then going into the field raw data book. Are there SOPs on site during the procedures? Do the SOPs reference accurately current procedures? Have they been approved by management? Are there any provisions for remedial action? And have they been reviewed in time? Are there an adequate number of personnel to do the work? Does the equipment meet the protocol requirements? Has it been properly cleaned, and is the cleaning documented? Is there an SOP available for the equipment that is being used? And are there logs? And are they up to date? Is the equipment in good working condition? And how about protective clothing? In the field data book, have personnel signed the field data notebook? Have the field data been checked at the time of activity? Or field data compliant, GLP compliant? And then you have a space there at the bottom for any comments that you have. Okay, next page. So does the plot design meet the proper size for the protocol? Is the plot adequately identified and flagged? Is the control upslope and upwind from the treated? Okay. So can anybody tell me why you would want the control upslope from the treated? If you think you know the answer, you can type it in the chat box. The plot layout, is it neatly drawn? Does it have a sufficient amount of detail? Does it reflect the actual design? Does it include a fixed point of reference? Are the dimensions given in proper units? Do they indicate the slope, north direction, and distance between the treated and untreated plots? So nobody has come up with an answer for the question about the slope, and are the control plots upslope from the treated plots. So let's say this is the field, right? And this indicates the slope, right? So it's going downhill. That's very steep. It'd probably be more like this. All right, so there's been an answer. Entered pesticide can run off from the higher side of the slope to the lower. That's correct. So the higher side can run off and go down to the other plot. So you want your control higher than your treated, because it's not going to run uphill, right? And then there's been a second answer been provided because of drift. So usually wind will usually flow also downhill, or there will usually be a certain predominant direction of wind. And so somebody has provided the answer, drift. That's correct. You would want the wind to be going from your control plot to the treated plot. If it went the other way, that means the drift can move on to your control, and that wouldn't be good. Okay, now going back to the SOP check, the checklist for the QA in life audit. Has the crop state been specified in the protocol? Is the SOP available and followed? Is the SOP available for the maintenance of the test plots? Scroll down on the next page, please. Are the measurement techniques accurate? Are they using proper measuring devices? Is the data recorded to correct significant figures? And is it calibration adequately documented? Now, I mentioned there could be answers of either yes, no, or not applicable. So here it says scale, balance, or weights certified within the time frame outlined in the SOP. Well, if you're using a powder or a granule, that's something you would generally weigh, right? But for a liquid, you usually measure the volume, right? So this wouldn't be applicable if you were using a liquid test substance. Okay, is the equipment log up to date and is it complete? Are the data recorded to the significant figures? Does the equipment appear in good repair or good shape? Is the application equipment acceptable? Also the technique, the calculations, and is the SOP available? Were past times taken? Were there any problems with the application? When was the mixture made? What time? Batch lot number. That's something that the test substance would have on it. Generally, the registrant will assign a number. Was the test substance stored according to the label? Does the test substance have a name, a CAS or a code number, batch number, expiration date, how to store it, and the GLP status? Is the test substance use log completed and correct? Is the application interval, are they following the protocol? And does it meet the specified rate? Is environmental equipment used according to SOPs? So things such as taking the humidity, temperature. Okay, can you scroll down, please, to the next page? Okay, so you've completed the application. Now you're doing sampling. Obviously, these are different. These are the different phases which can be reviewed. Okay, so is the sampling as per protocol? Is the PHI met, pre-harvest interval? Are there methods to control bias? Is the sample collected in the proper order? Is there a description of the collection, harvest, cleaning, trimming, and are cutting documented? Is there prevention of contamination? So whatever you do in the field, you always, and of course the laboratory too, when you're handling samples, you want to have clean gloves, and you want to handle the untreated control first, and then move to the treated plot. So it's asking, were gloves worn during collection? Was the sampling equipment cleaned? Was the sampling equipment stored separate from the test substance, right? You wouldn't want to have to use a clipper to cut something, and then that clipper was stored with the test substance, or else it might be contaminated. Is there adequate separation between the test substance and sample storage areas? Okay, can you scroll down to the next page, please? Okay, storage and shipping. The freezer inventory maintained. So when you have a freezer, you have to keep a log with an inventory of everything that is stored within that freezer. Are the treated and untreated adequately separated? Is the sample handling in the proper order to prevent cross-contamination? If there was shipping involved, was it done according to the protocol? How was it shipped? Are the forms filled out properly? Have the storage conditions adequately been maintained according to SOP and protocol? You scroll down, please. So then, you've already completed the checklist. So then, any place where the QA has a finding means that the QA finds something that they notice that is of concern, that something maybe might not be meeting SOPs, it might not be meeting the protocol, or something was done differently than the protocol. So they would list all of these on this page, on the column here on the left side. So they would write their findings here. And then the field research director or the study director, if they're knowledgeable of the situation, can respond to these particular actions. Okay? And you scroll down to the bottom. So then they sign and date. And that's the in-life audit form. So these forms are used by QA to conduct the audit. Is there any question about the auditing process or in-life? There are also QA reviews for the notebook as well. In other words, after the notebook is completed, they will audit the notebook. Well, we aren't going to be covering that today. All right. I think, have you scrolled down to the bottom? And then it's just a final area for summarizing the responses and actions. Okay. So that completes that part of the agenda on quality assurance auditing. Okay. Next is sprayer calibration and walking speed. So I have a presentation, I believe it was a PowerPoint. If you can please get that up. All right, I think that looks like the right one. All right. Are there any questions over the audit process? All right. Can you scroll down to the next slide, please? So I hope you had a chance to look at some of the YouTube videos that we had posted. I provided links to some of these processes. So what you see here is a picture out of the video whereby they're calibrating a sprayer. So this is the sprayer that when they calibrate, they're only calibrating with water, right? So this particular sprayer has 3 nozzles. There's a nozzle here, a nozzle in here, and a nozzle in here. And so they're using these 3 containers to catch the output from those nozzles. And you could also see this person has in their hand, that little thing here in their hand, that's a stopwatch. So they're taking the time. And then that time will be recorded on how long they utilized to collect the sprayer output. Of course, these days, it's a little less common to use a stopwatch. Most people will use their cell phones, right? Because you have a stopwatch on your cell phone. So you can use your cell phone as one of your pieces of equipment. Next slide, please. You can scroll down. Okay, so this is one of the larger, I think probably the largest group field training that we held. And you can see that it was on January 29th through 31st, 2013. So here I am wearing a yellow shirt. And I could recognize a few of the people here. There you are, Sri, excellent chemist from Indonesia. Let's see who else we have here. Let's see, we have Mohammed Sharon down here. He's from Malaysia. Standing next to me, we have Mr. Nan from Malaysia. Dr. Wu, he's a chemist from Singapore. I forgot the name of this individual, this woman here in pink. She's a quality assurance officer from Singapore. This lady is Miss Jamalaya from Malaysia, who's a quality assurance officer. This was Dr. Jacana, who represented the Philippines. So some of the countries and some of the individuals have been here. Oh, yes, Dr. Tung, yes, you're standing right here next to me, right? Yes, Dr. Tung from Vietnam. So some of people have persisted on. I see a few other. Now I recognize here Miss Panida from Thailand, who did the quality assurance auditing on the field work. And a lot of other Thai participants, some who were involved in the field aspect, some in the laboratory aspect. All right, next slide, please. So we let the conditions dictate when we have to calibrate. If we are short on time, if we are concerned about wind is usually the lightest at daybreak. So occasionally we even calibrate in the dark, and we've done this. So here, this is in the Philippines, in the island of Cagayan de Oro. And here we're using the lights of the truck to prepare our equipment to get it ready for calibration. And that was a successful application. All right, next slide, please. All right, so every protocol, has its own directions, and don't mistake these directions as your directions. This is just an example. Okay. So the protocol stated that they needed to have 4 plots plus 1 control and 3 treated plots, at least 20 meters apart. Calibration, a requirement of 3 consecutive times within 5%. And they needed to apply 400, 500, and 600 mils of formulated test substance per hectare in an 800 to 2,000 liter per hectare spray volume. And they needed to make 2 applications 14 days apart. The target pre-harvest interval was 3 days. And then they had to collect 2 untreated samples and 2 treated samples. They had 24 fruit per sample and 3 days after the last application. Next slide, please. They conducted a full calibration, and then on the day of application, they did a recheck. Slide, please. So some of the information they had to collect was on the name of the test substance, the batch lot number, the test substance expiration date, who received it, any tracking information, and the approximate amount received. Next slide, please. A description of the container, and this is all information that you will be prompted to include in the field data notebook. Next slide, please. There's a space to put in a map, and this is an example. This is for directions to how to get to the test site. Next slide, please. Individual information on the plot plan. Can we increase the size a little bit, please, Nui? Or make it full screen? So you could probably have some control over that within your own presentation on your screen. Okay, that's a little bigger. Okay, so a few things here. You can see that each plot had 1, 2, 3, 4 rows, right? And then it's telling you how wide the plot is, how long the plot is, what the spacing is between the plants within the row. It tells you which direction is north, as indicated by the N. It tells you what the prevailing direction of the wind and the slope direction, and also what percent. And then also, these plots have to be marked. Not only markers on the plots themselves, but they also be compared to a permanent marker. A permanent marker may be something such as a building, could be a well, it could be a water source, it could be a telephone pole. A permanent marker is something that generally doesn't move. So hopefully buildings and telephone poles don't move too frequently. So you determine a point and you measure the distance from that reference point. Okay. Next slide, please. So you give information about the crop itself. Next slide, please. Any cultural practices, any maintenance fertilizers and pesticides that you used on the crop. Next slide, please. Application records include, first of all, a diagram of the equipment. Next slide, please. Your discharge calibration records, how you calibrated the equipment, who did it, and the discharge units, such as mils, ounces, gallons, liters. Next slide, please. How did you determine the output? So there are different ways to determine output. So back on the very first slide, you saw some containers which were catching the output of individual nozzles. You can also do it by what's called the backfill method, and we'll describe that. Next slide, please. So you have a space in your field data notebook for the run, the amount of time that it took in seconds, the initial volume, the volume discharged, and the final volume. So you would enter that information with a pen, right, into the field data notebook. Next slide, please. So you'd be describing how you mixed up the test substance, and you'd have spaces for your calculations as well. Next slide, please. And then give details on which treatment number. Is this the first treatment if you have multiple treatments? Who applied it? What time? What equipment did you use? How did you place the pesticide? Was it a soil treatment? Was it a foliar treatment? What is the amount? How much did you mix up? Was the starting volume of the water that you used? Did you remove some of that water? Did you use the test substance? How much? Next slide, please. So then also some information about the weather. So what direction did the wind come from? North, northeast, east, southeast, south, southwest, west, and so on. Or maybe no wind. Estimate of the percent clouds in the sky, relative humidity, and remember, what will you be using? You could use a hygrometer, or you could use a sling psychrometer. Remember that? Dew. you're not really measuring the dew. You're just stating if any dew is present. In other words, is a heavy amount of dew, light, or none? Description of the soil tilth. Is it smooth, firm, packed, cloddy, etc.? How much soil moisture is there? Is it wet? Is it moist? Is it dry? Etc. So all of these things, there'll be spaces for these in your field data notebook. Next slide, please. So you also will be having spaces to collect information on your harvest. And we do not cut any samples in the field. Okay. Next slide, please. We'll also be including information on your temperature logs, and minimum and maximum temperatures, date, and initials. Next slide. So at the beginning of the notebook, it has instructions. And these are some of the instructions. So all the entries should be clear, understandable, and made with pen. If you have to make changes to the raw data, draw a single line through the original. Okay? Make sure you don't obscure it. The date, signature, initials, and the reasons for change. Use one of the error codes. You could use the error codes in the book, or some people also have error codes as part of their SOPs. So rather than writing out the whole reason, they just use abbreviations. Okay? So ME can mean if there's a measurement error, CE can mean calculation error, NR means not recorded, SP is spelling error, and so on. You can use these if you like, or you can develop your own. Whatever you use, it has to be documented and the codes must be outlined either in SOP or in the notebook. Next slide, please. So you'll commonly have SOPs archiving the data, recording raw data, rounding numbers, measuring liquid chemicals, receipt, storage, and disposal of test substances, calibration, cleaning, and maintenance of your spray equipment. Next slide, please. All right. So this is an aerial view of a field. I think most likely citrus, although I'm not sure. And you can see that I've kind of like designed like a box around it. And this is supposed to represent the area that this tree is occupying, right? So it's not only occupying the circular area that it is, but also there's spacing between these plants. So it's actually occupying from the center of one row to the center of the next row. And then also center to center within a row. Next slide, please. Okay, so we'll be working with a number of different crops. Here we have dragon fruit. Next slide. These are peppers. The slide is not very good, but then again, you can see that there are distinct rows. In other words, there's spacing between plants within a row, and there's also spacing from one row to the next row. And you can see the tractor wheels within the valleys. So the tractor has been driving between the rows. Next slide, please. These are just some other fields with some other crops that we're going to be using, such as basil and a type of greens. Okay, that's okay. You can go to the next slide. Thank you. Okay, So the plot size is based on the space that the trees or plants occupy. So the spacing that they occupy is the distance between the center of one row to the center of the next row. And then there's also spacing within a row from one center of one plant to the next plant. And we take about 10 measurements, so we get an average tree spacing or plant spacing within a row and between rows. Okay? And then we know how many trees we would want per row, and that gives us the size of the plot. So the plot size in square meters equals the tree spacing, the length by the width times the number of trees. So that's the plot size, right? And that's the number of square meters. If you take those square meters and divide that by 10,000 square meters per hectare, you'll get the plot size in hectares. Okay. Next slide, please. So you know the plot size in hectares, because you just calculated that. From the protocol, you would find the target number of liters per hectare. And if you multiply those together, you're going to know how many liters you need to cover the plot. Okay. Next slide, please. So let's say you had a plot here with 6 trees or 6 plants. You can't cover all of them necessarily all at the same time, especially if we're dealing with tall trees. You probably have to treat them from one side and then come back on the other side and treat the other side of the tree. So each time you're walking from one end of the plot to the other end of the plot, that's called a pass, and you need to record your pass times. So you're walking from one end of the plot to the other, and you're spraying the tree as you're walking past, sort of like you see here in this figure. So if you have 2 rows, you have to make a total of 4 passes to cover both sides, right? So we already determined our plot size in hectares. We knew how many liters we needed per plot. We know that we have a total of 4 passes, and then we know how many liters we need each pass. Next slide. Okay, so this is in Vietnam, project on dragon fruit, and you can see there's a sprayer there, and he has a pen or a magic marker, a marker in his hand, and what he's doing, he's marking the level of the water inside the tank. Okay. Next slide, please. In addition, there's a marking here of where the sprayer is on, in this case, it looks like some type of a plastic sheet or something. So he's making sure he knows exactly where the sprayer is sitting. Okay. Next slide, please. Again, this is the bottom of the sprayer, and they've taken a magic marker, and you can see the blue line here. This blue line is an outline of the sprayer, so that if you take that sprayer off of that spot, you know where to put it back, because you want to put it back in the same area, and I'll explain why. Next slide, please. So there's an outline of the base of the sprayer, and that's on concrete. So you can come back and you can see that again. Next slide, please. This is another a little more sophisticated situation. So they don't have a concrete pad to work on. So they brought their own pad made out of wood. So they selected a spot that was at least level in one direction. And this wood will stay in place. It was nailed into the soil. And you'll also notice that they put smaller pieces of wood to surround the base of the sprayer, so they know exactly where that sprayer belongs. Why? If you remember, the initial part was marking the sides of the container. Remember the first scene that I showed you with the gentleman in Vietnam marking the level of the water inside the tank? Okay, next slide, please. Okay, I'll go to this. Okay, so once we know the number of liters per plot, and we know the output, how many liters per second, we can then calculate the total seconds needed to treat the plot. But we're not going to treat the whole plot at once. We're going to treat it in 4 passes, right? We're going to go on one side of the tree and then come back on the other side of the tree as pass 2. Then we go on the other row, we go pass number 3, come around, and do pass number 4. So the total number of seconds to treat the plot, if we have 4 passes, that tells us how many seconds we need to walk for each pass from this point here, where we start, to that end of the plot. That's the number of seconds it takes for each pass. Next slide, please. So we have a formulated test substance rate. You would find that in the protocol, right? We already know what our spray volume is per plot, and we know what our spray volume is per hectare, which is also in the protocol. And you take that and you multiply that by the test substance per hectare, and that equals the volume of the test substance per plot. Next slide, please. So the test substance rate is actually the volume of the test substance divided by 4. Okay. Okay. So we determine here in this particular area, each tree is occupying 36 square meters. 6 meters by 6 meters. Next slide, please. So if the tree spacing is 6 meters by 6 meters, and we have an area with 12 trees, I'm sorry, this one is only showing 6 trees. But anyway, if you had 12 trees, it would be 432 square meters divided by 10,000 square meters per hectare, and that tells you how many hectares there are in your plot. Right? Next slide, please. So if you have 12 trees and you have that many hectares times 1,100 liters per hectare, you need 47.52 liters in 4 passes. So each time you pass, you need to have a mixture of at least 11.8 liters for each pass. Okay, so if you were to calculate 11.8 meters needed per pass, would you mix up exactly 11.8 liters? Would you make more? Would you make less? Why? Anybody want to try to answer that question? If you want, you can try to answer in the chat box. Okay, so somebody provided an answer, more. So why would you want to make up more than you need? That's the correct answer. You would want to make more. Why? So Dr. Farag or somebody else, why would you want to make up more? let's say that this person here, this photo, can you see my cursor around? He says more to overcome any loss. Okay, not exactly. But let's say this person is carrying this spray equipment and they can hold, let's say this tank holds 20 liters. Okay. And they determine they only need 11.8 liters. Okay. And so, okay, error or deviation. That's correct. So this person, it's hard to tell, but he's walking alongside of these trees while he's spraying them. And so if he walks too slow, he will run out of the spray before he reaches the end of the plot. And that's not good, right? So remember, you're allowed a certain amount of error. Does anybody remember? How much error are you allowed to go over? How much percent? I have an answer of 5%. Does everybody agree with that? Okay. So 5% is correct for the calibration. However, for the application, we are correct. Here we have an answer of minus 5% to plus 10%. So if you were to go over, or if you were to walk too slow and you didn't make up extra, then you would run out before you get to the end of the plot. So you may be, let's say you are 9% over the acceptable rate. Your application would be okay. However, if you run out of the spray, then that's not okay because you haven't treated the whole plot. All right? Next slide, please. All right. So pass time, it depends on the sprayer output and walking speed. Assume the sprayer output is 3 liters per minute, 11.8 meters per pass. That's what we calculated earlier, divided by 3 liters per minute. That's how much the sprayer is putting out. We need to take 33.93 minutes, or 3 minutes and 55.8 seconds each pass. So that's our target pass time. Next slide, please. So we have a known spray and our test substance. We want to apply at 517 mils per hectare over 12 trees, which occupy that space. So we want to apply 22.334 mils per plot. So we're going to mix up 21.6 mils per plot in 4 passes, or 5.1 mils per pass. Next slide, please. So again, I've already asked this question, but if you have 5.4 mils per pass, if you have 4 passes and the amount of water you need is 11.8 liters, should I prepare exactly 11.8 meters of water and add 5.4 mils of the test substance? No. You should make more, remember? Because you could run out. Next slide, please. So what if I walk too slow and run out of spray? So the target is minus 5 to plus 10%. So we generally suggest making about 20 to 25% extra. We call this overage. And there are a few reasons why we do this. First of all, we want to make sure we don't run out. Second of all, when we start the sprayer will usually have like a trigger that you will press, right? And then the spray will come out. you want to make sure that that is full. You want to get all the air out of the lines. So you will be using some spray just to fill the line, right? And depending on what kind of sprayer you use, that could take a significant amount. Okay, next slide, please. So adding overage, if you are increasing by 20%, here we're taking our 11.8 liters and multiplying it by 1.2, giving us a 20% overage. And that equals 14.16. And we're just rounding that off to 14 liters. Okay. So if we want to apply 500 mils in 1,100 liters, how many mils do we need to add to 14 liters? And the answer comes out to 6.36 mils. Right? So it's not easy, it's not convenient to measure 6.36 mils in the field. It's a lot easier to measure 7 mils, right? So instead, you just do some simple algebra and you determine that you can round it to 7 mils and you would add 15.4 liters of water. Next slide, please. So practicing pastimes is very important. So here we have the person doing the spraying. This person is holding a stopwatch, or you can use your cell phone as a stopwatch. And he is walking along this line. So that this plastic line is indicating how long the plot is, and he needs to walk that distance in a certain amount of time in order to have the proper pass time, which means that you put out the proper amount of spray. Okay? So how do you have a good pass time? How do you do that? Lots of practice. Next slide, please. Let's skip over this slide. Next slide, please. Okay. So, did everybody do their homework? Okay. Did you do your homework? I asked you to do two things before the meeting. I asked you to look at the YouTube videos. And I also asked you, if you have a cell phone, and you download this app. This app is called Metronome Beats. It doesn't cost anything. They don't charge you for this metronome. You can get this at the Play Store, or there's also a version for Apple, for either Apple or Android. So I have this app on my phone. See if I can get to it. It's probably hard to see on the screen, but I will try. So if you can see the little green square, that looks similar to what you see. It's like a green square with a white line in it. It's an app called Metronome Beats. Does anybody know what a metronome is? Can somebody describe what a metronome is? You can provide the answer in the chat box if you like. Okay. So, do we have any musicians in this group? Anybody play like piano or some other musical instrument, drums, where you have to be concerned about the beat? Okay. So does everybody have a hat? Because we're going to be going out to the field. See, I'm getting ready to go out to the field now. Can you come with me? Okay. So luckily for me, the field is right in back of me. and this is our field. Can you see the field? So we have two crops growing here. One crop is basil. Okay. This is basil, or also known. You're going to be using this crop in Laos, right? In Thai Holapa, this crop. Okay. Many of you are going to be working with chili pepper, right? Okay. So here's our field. Of course, we wouldn't really have both crops in the same field. I'm just using those just as an example, okay? Because those are two crops that we will be including in some of the studies. Okay, so if you have this app called Metronome Beats, you can use it to make a sound, okay? And can you hear the sound? Okay, now follow me back out to the field. I hope you can still hear this. Maybe I'll leave this at my laptop so you can hear it. So every time that you hear the beep, you're supposed to take a step. Okay? So let's say this is the plot. I have the sprayer on my back. And then every time there's a beep, I take a step. Right? And then I'm coming from the other side of the plot with the sprayer. So every time you hear the beep, that's when you take a step. Okay? I'm just making believe like I just sprayed a plot, right? And I would use this free app on my phone to know when I should be walking, the pace. Every time you hear the beep, you should be taking a step. Okay, so, well, there are other things you can do with this app. Okay, if you're a very tall person, if you're a person that tends to have very long legs, your stride will be very long, and so you would want to have a slower beat. If you are short, maybe you need a faster beat. So you can adjust the beats. So you can make it slower. This is very slow. Or you could speed it up. And you can adjust it anywhere in between. The main point is that what you're doing is you're hearing a sound, and you could use that as a guide to how fast you should walk. Okay? Any questions about that? So this is a free app, and you can adjust the speed of the beats. And you just adjust it so that your pace will result in the proper pastime. Anybody have any questions about that? All right. Okay, so we're finished in the field. And now we just came back. And I'll stop my phone and put it down. All right. Any questions about what a metronome is? So this little picture here, that's what a really old metronome would look like. And it would go like back and forth like that. And every time it would make a beeping sound. Okay. But the modern one we can have on our cell phone, and it's free. Okay. Next slide, please. Okay. So this is the very first trial that we had in Malaysia. And so here you see Muhammad Sharon walking away. This is a quality assurance officer. This might be Nan back here, not sure. But anyway, they're only working with water, so don't get excited. They're only working with water. And you see I've drawn red lines here. So every time you walk, there's a certain distance between your feet, right? So when you walk, there's a natural distance between your feet, see? And different people have different lengths of their stride. It's just your natural distance as you walk, okay? So if you combine the distance between your steps and you control how frequent the steps are by the metronome, you can develop a constant walking speed, right? And so you just keep playing with your metronome and you're knowing your target pastime. You know how fast you want to walk to be able to have the proper pastime. So you have to be a person that is good at keeping a steady pace, being able to respond to the frequency of the sound, and keeping a consistent difference in your stride or the distance between your feet. Okay. Are there any questions? All right. So again, you can watch the GLP field training video. It can give you some ideas on how these studies actually look, although it's not, none of this is identical to what you're doing. It's just giving you an idea. Okay. Next slide, please. All right, I guess that's the end of the presentation. Are there any questions on the calibration and application? Does everybody understand the relationship between your sprayer output and the way in which you're calculating pastimes? Okay. So there was one part of that presentation that I seem to have been missing a slide, or maybe I forgot to include one. If you recall, during the process, when you were looking at the sprayer in Vietnam, remember they had the sprayer and they were drawing a mark on the sprayer where the level of water is, right? So if you have that mark and you have a specific spot for your sprayer, when you start spraying, the volume of the water is going to go down, right? So the volume of water decreases as you're spraying over time, and you spray for a certain amount of time. It could be 1 minute, 3 minutes, 5 minutes, until you dispel a certain amount of liquid. You don't know what that is. You know your original line is where you made the mark. And this is the amount of water after a certain amount of time. So what you would do is you would take a graduated cylinder, fill it with water, and then you pour it back in until you get back to the original mark. And that's telling you how many milliliters you dispersed in a given amount of time. Is that clear? Okay. If you don't quite exactly follow that, don't be concerned. This is an initial virtual field training. We don't expect you to understand everything here. It's just to understand the general concepts. And we will be going with you one-on-one for whatever we need to get you ready to be able to make a successful application. And you will be successful. All right. So the final part on today's agenda, what are some of the equipment needs? Okay. So these are some of the general items and equipment needed for the conduct of GLP residue studies. You need some type of sprayer, and that depends on what your crop is. It could be a mist blower if you're working with tree fruit. It could be a knapsack sprayer. Sorry for my alarm there. Or some type of sprayer for the treatment of your applications. You could use a metronome or a phone app to help you keep pace when you're making the application so you can time your steps. You need some environmental monitoring equipment for wind speed and direction, air temperature, relative humidity, and you're going to be taking that data at application. A thermometer that you can stick in the ground at least about 4 inches to get the soil temperature. A pH test strips to test the water when you mix the test substance. You'll need graduated cylinders, beakers, pipettes, etc. for measuring the test substance and water carrier. You'll need water jugs or something to carry water to the field. I don't know, maybe you might have a building that's close to where you're going to put the plot out, and you can use that as your source of water. You need some type of flagging. Flagging is just like a plastic strip, and to stop people from entering your plots. You need plot markers to identify and delineate the field plots. You may need a ladder for harvesting, that's possible, but in most of the crops that we're working with, no. So work with dragon fruit, basil, chili pepper, greens, and rice. So you shouldn't need a ladder, right? Bags for collecting samples, they should be waterproof sample bags, plastic, or ideally plastic-lined cloth bags. All right. You'll need some kind of safety equipment, depending on what is indicated on the products that you're using. You'll need an ice chest and either wet ice or a chemical blue ice pack for helping to cool off the samples once you harvest them. And you need to have a separate ice chest for treated samples and control samples. Right? You'll need some data loggers for test substance transport to determine the temperatures during transport, and also for the transport of the samples. Possible data loggers for shipping containers, although for most of your work, you're going to be delivering it to your own laboratories or somebody else that you're cooperating with in your own country. and you're going to be doing that probably by car or a pickup truck, or so you won't need to actually ship the samples. In the office or laboratory, you're going to need a small refrigerator, the storage of the test substance, to keep the test substances from excessive heat, although you may have a room where you keep your test substances. And it doesn't necessarily need to be refrigerated. It can simply be something that has like an air-conditioned area. It really depends on what the manufacturer's recommendations are for the storage. You'll need a data logger also to record the temperature of the area where you're storing the test substance. You'll need freezers for storing the samples and also for monitoring the temperature of the freezers. Ideally, although it's not required, it's good if you have a backup electrical system, like a backup generator for example, for your sample freezers. And ideally, an alarm to alert you of personnel that there's been a freezer failure. And you need to have a plan in place. What happens if one of your freezers break? So you should be setting up something cooperatively with somebody else that also has a freezer, and in case of emergency, you can quickly transport the samples to another freezer. And you would want to do that on ice. And that, for the most part, is the field equipment that is needed to conduct one of these studies. And at this point in time, I'll take questions. Are there any questions over anything that I've covered? So if anything, the most important things are really to be able to successfully make the application within either -5% or +10% of your target, and to have everything that you do well documented in the field data notebook. Those are two of the most important things. The success of your application will depend on your calibration, which is done before the application, and then also your practice of your walking speeds and knowing how to adjust your sprayer for a constant output. And again, with that, I think I have completed my presentation, and I will open for any questions you've had on any of the field training program that I provided today. Are there any questions over anything that I've covered? Okay, so everybody's ready for their test, right? No, I'm only joking. So no, there's no test. The real test will be when we have the field trials. But we will do lots of practice together with water. And so we will practice and practice until we get it right. And so when we make the actual application, you will be on target. Okay, so there's a question for sampling. Will the field manager take the sample to the lab? Yes, that would be the proper thing to do. It really depends on a few things. I would say that's probably the most common. So you would take the samples, you would collect the samples in the field, you would have them in a ice chest for control samples and ice chest for treated samples. You would take them to the lab and you would place them in the freezer. If it's necessary to reduce the volume, such as maybe with dragon fruit, you may want to divide the samples and section them into quarters so that you can reduce the volume and the space in your freezer. It also depends on what the distance is between the location of where you're doing your field trials to the lab. Okay? So you may, if you have a freezer available, if the field research manager has access to a freezer that's closer to the field, they may want to take the samples to that freezer and make sure that they're frozen first, and then transfer the samples to the lab later. Okay? You also want to alert the lab, hey, I expect my last application to be on this date. I'm going to be collecting the samples on this date. Do you have room in your freezer for the samples? If not, you better go to your backup plan. Remember, you're going to have a backup plan in case you run out of electricity, or what if you run out of space? Okay? What if the laboratory freezer is full and they can't hold all of your samples? You can't just wait until the freezer is empty. You have to do something with those samples immediately, and you have to put them in a freezer. Okay. Or what if you run out of electricity? Again, it depends on how long you run out of electricity. What you should be doing, ideally with your freezer should always be full, either full with samples or full with ice. Okay, so how do you make it full with ice? So I assume all of you have access to some plastic bottles. Maybe in your country, they sell soda in bottles, in 2-liter plastic bottles, or maybe smaller bottles. So I would fill them up about 3/4 of the way with water and keep them in your freezer. Okay? And then when you get samples, you want to put the samples underneath those frozen bottles of water. And if you run out of electricity for a brief period of time, that will keep your samples frozen, even if without electricity. If it's a situation where your freezer goes off for maybe 15 minutes, an hour, maybe 3-4 hours, that's probably about the limit. If it's more than about 3 or 4 hours, you need to immediately transfer them to another freezer. Or if you have a place you can get ice or dry ice, you need to bring it in to keep those samples frozen. If those samples thaw, they're garbage. And all the work you did in the field, it's no good. Okay, so it really depends on how frequently you have electrical problems and how long does it take for that electrical problem to be fixed. Hopefully you should have somebody else that you know that has a freezer that is available. So in case of emergency, if it's just an electrical problem at your lab or your district of the city or something like that, you can bring it to another laboratory somewhere else and they still have electricity. Okay? So I hope I answered that question. There's another question. What about the sample size and guidelines followed for sampling? So where do you think you would find the sample size? So it depends on the crop, right? So FAO, EPA, they all provide guidelines on what the sample size is. And we use that information. And where do you think we put that information? Where would you think that you would look for that information? If you were about to harvest and you said, I'm growing chili peppers, and I know I need to harvest a certain number of them, but I don't know. How many am I supposed to harvest? Where would you look for that information? Anybody want to try to answer that question? Where would you look for knowing what the sample size should be? Anybody want to try to guess? You could write your answer in the chat box. Okay, so since nobody has answered, I will tell you. You would look for that information in the protocol. So the protocol should tell you how many is the minimum number of fruit or minimum number of whatever it is that you're harvesting. And then it will give you the guidelines on how to harvest it. Okay? And then you will document that in your field data notebook. What happened if you received a protocol and it didn't say how many chili peppers you needed to harvest? What would you do? Let's say you received a protocol. You're looking at a protocol, and it doesn't say how many chili peppers to harvest. What are you going to do? What do you think is the proper thing to do? Well, hopefully you read the protocol before it's time to do the work, right? And if you look through the protocol and you're reading the protocol and it doesn't say how many chili peppers to harvest, well, you should contact the study director. And then what do you think the study director would do? The study director would issue a change, okay, or amendment. All right? Because that should be in the protocol. If it's not, it would need to be added. Okay, so there's another question. Plus 10% enough sample for analysis. Okay, so I think the question, well, when you say plus 10%, do you mean plus 10% in the number, or do you mean 10% in the weight? Because the way we express it in the protocol, we tell you the minimum. The minimum means the least amount. So you need at least that much. So let's say the protocol said to harvest 12 dragon fruit. And you harvested 15 dragon fruit. That's fine. You can go 10% over, you can go 20% over, you can double it. It doesn't matter, as long as you meet the minimum. And the minimum would be found in the protocol. Okay? Remember, we went over that protocol section where there was a table that told you this is sample A, B, C, D, E, whatever. And then it tells you what the minimum amount as far as the number of dragon fruit, and then the minimum amount of weight. So it varies by the crop, but that will be included in the protocol. So as long as you meet the minimum, there's no problem. You could be 10% over. So here there's I think an answer depends on the number of sample and the size of the sample storage. No, it does not depend on the size of the sample storage. You have to follow the protocol. Now, you can harvest the minimum, and then if you're over, you can reduce the sample size by sectioning the sample. It's kind of hard to section chili peppers, but you can subsample chili peppers, right? And then you can reduce the sample size. So you need to determine whether or not you have adequate storage space before you start the trial. All right? Are there any additional questions? Okay, follow the protocol. Right. Very good. And if you couldn't find it in the protocol, what would you do? Contact the study director. If the study director says, uh-oh, that's not right, well, they would need to issue a change. And hopefully that is before you harvest, right? So that it becomes an amendment, not a deviation, right? So it's always better to make the change in the front. So let's say the protocol didn't tell you how many to harvest. So the study director would need to develop a change to add to the protocol. And so they would have the protocol number, the study title, and then they would say what section of the protocol that they would be changing, and that section would be the harvesting information. And then they say, well, what are you actually going to change? Well, we're going to add the following information to harvest this many chili pepper or this many dragon fruit as a minimum number of samples. And then you have to say, well, why are you making this change? And the answer would be, you're making this change because there was an error when the protocol was developed. In other words, somehow they left it out. They forgot to put that information in the protocol. And then would require the signature of the study director and their management. Okay? Are there any additional questions? If not, I thank you very much for your time and patience and attention. I will be holding another session tomorrow, starting at the same time, which is 6 a.m. New York time, 5 p.m. Bangkok time, and we'll carry it on from there. Again, I'd like to thank the people that are kind of in the background. Sel, who is assisting on managing the Blue Jeans platform. And then also, thank you for Nui for managing the slides and all the presentations. So thank you very much to both of you. So we look forward to seeing you tomorrow. All right. Thank you, and have a good night's sleep, or whatever it is, depending on the time where you're at.
Okay, thank you very much.
Thank you very much. Hello, Santi. Hello to the group in Pakistan.
Bye, Michael.
Bye, Michael.
Thanks for such a nice presentation. See you tomorrow.
Okay, see you tomorrow. Thank you for participating.
Thank you. Thank you. Thank you.
Thank you for everybody for participating. All right. So we still have 38 people on the line. If anybody has any questions, please, you can still type them in the chat box. Okay? If not, you can also send me an email.